Hey y'all, welcome to Algebra class. This is the first video for my series on algebra coming from my class. This is lesson 1 in our book. This lesson is actually made up of 2 parts. I'm going to do the first part here. It's on fractions, just adding and subtracting fractions. So this should just be review, but let's make sure we remember it before we move on to other stuff. To start off with, I've got a couple of fractions, and we're going to add fractions with the same denominator, and we're going to subtract fractions with the same denominator. Remember, you can add and subtract fractions as long as the denominators are the same, and in these problems they are. What we do is the denominator stays the same in our answers. Other than that, we just add or subtract the numerators like we always would. 5 plus 2 equals 7, and so our answer is 7/11ths. And here 5 minus 2 equals 3. So our answer is 3/11ths. So as long as we've got the same denominator, we can add and subtract fractions easily. But life doesn't usually treat us quite that good. Usually the denominators aren't the same, and we have to change them so that they are. So let's look at a couple problems where we have different denominators. We'll find a common one, and then we'll add or subtract them. Let's take a look. All right, here's a couple examples where we have fractions with different denominators. What we'll do is rewrite each one so that they are the same denominator. So this first one, my denominators are 3 and 5, and what I want to do is get a common multiple of those two numbers. So if you look at 3, multiples of 3 would be 3, 6, 9, 12, 15, 18, so on. Multiples of 5 would be 5, 10, 15, 20, so on. So 3 and 5, a common multiple they have is 15. One easy way to do it is to just do 3 times 5. We get 15. So that tells us both fractions can actually be changed to a denominator of 15. This first fraction, 1/3, we can multiply it. Now here's a really good example of a subtraction problem where we're going to run into a problem. We're going to have to borrow. I'll show you why. We've got whole numbers that have fractions with them. We call these mixed numbers. And a lot of times what we can do is just combine, or in this case subtract, the whole numbers and then subtract the fractions. Again, to do that, we're going to need a common denominator just like before. And from 5 and 8, I'm going to get a common denominator of 40. So let's look at what happens. I'm still going to have the whole number 13, but I'm going to multiply this fraction by 8/8. That's going to give me 24/40ths. And then I'm still going to be subtracting. I'm still going to have the whole number 2. But I want to get 40ths from this fraction as well. So I'm going to multiply it by 5/5. And when I multiply 7 by 5, I get 35/40ths. So here's the problem. My whole numbers are good. I can do 13 minus 2. But I run into a problem trying to do 24/40ths minus 35/40ths. And so the solution of that problem is I borrow one of my whole numbers from 13. I'm going to take a whole number away from 13, which gives me 12. And from that whole number, I'm going to split it up into 40 parts and get 40/40ths, which is that one whole number. So I take one away from 13. I borrow 40/40ths from it, and I add those 40 to the 24 that are already there. That means I now have 64/40ths. So 12 and 64/40ths is another way of writing 13 and 24/40ths. They have the same value, so we're not changing the number, just changing the way it looks and putting it into a more useful form. Because now we can subtract easily. Our whole numbers would be 12 minus 2, which would give us 10. And then our fractional part would be 64/40ths minus 35/40ths. And if we work that out, that's going to give us 29/40ths. So we get an answer, 10 and 29/40ths. We did it through borrowing. Now there's one other section to this lesson, and it actually uses what we just did. But it's based on line segments. So we'll go ahead and take a look at that and see how we can incorporate this into it. Now this second part of the lesson here is based on lines and segments. Later on in the book, we'll actually work with actual lines because technically a mathematical line goes forever in each direction. For right now, we're just going to work with a piece of a line, which is called a line segment. And we name line segments according to any points that may be on those line segments. This one has a beginning point of A and an end point of C, and so we call it line segment AC. Technically, you could read it backwards also, and it would be line segment CA. And what they do is sometimes in the book they're going to give us problems like this, where they tell us line segment AC is 10 1/4 units long. And what always helps me is I actually go ahead and draw my line segment and I label it what it tells us. It's telling us AC, which is the whole thing, I'm going to just label it here, is 10 1/4 units long, so 10 1/4. And then they'll also tell us that line segment AB measures 4 3/7 units. So I label that also. AB would just be the segment from A to B, and it's telling us that's 4 3/7 units long. And then it will ask us, what's the length of segment BC? And so what we do is we think about what information they've given us and what information they're asking us. They've given us the entire line. They've also given us one part of the line, and they're asking us to find the other part of the line. So to find line segment BC, we take the total and we subtract the other part to find the missing part. So we just set this up as a subtraction problem. 10 1/4 minus 4 3/7. Now, to be able to do this correctly, we need to get a common denominator, just like before. So, from 4ths and 7ths, we use a common denominator of 28. That means we get 10 7/28 minus 4 12/28. And we'll have to borrow, just like we did before. I'm going to borrow 1 from 10. That's going to leave me with 9. And that one whole that I borrowed, I'm going to split up into 28 28ths. So I'm going to add that to my 7 I already had, giving me a total of 35 28ths. So now I can subtract. I can do my whole numbers. 9 minus 4, I'll get 5. And then I can do my fractional part, 35 minus 12, and that's going to give me 23. So I now know the length of segment BC. It is 5 23 28ths long. And we didn't really give any specific measurement. We just said units, so I write U for my answer. And sometimes in the book, they'll give you both segments. They'll want you to find the whole thing. In that case, you would add. So you got to put your thinking cap on, do a little bit of thinking, read the problem carefully, and from that, figure out whether you're adding or subtracting, and you can put this into practice. All right, we'll get lesson 2 up pretty soon. I hope this is helping. If you have any questions, put them in the comments. Put anything else, any things you think I can add, anything like that. But I hope this does help, and I hope y'all have a good one. And again, thank you for joining us today.